Today we are discussing about the assignment number 10, which is depending on OBST. In previous session we discussed about the optimal binary search tree, which is called as an OBST. So what you want to do in this assignment, you want to just accept the keys and frequency, and we want to find out the minimum cost of that tree. So this is the input and output. So see, check out that this is the input and output regarding with that OBST. We want to performing this as an input, and we want to calculate the output by using the help of an OBST. So the input is the key values as an a node and the frequency. So which are the keys? We considering the three keys here: 10, 12, and 20, and the respective frequency of that 10, 12, and 20 is 34, 8, and 50. Means what? Frequency means what? 10 is 10 is find out or search 34 times in that tree. Then 12 is a node, or which is a key, which is find out 8 times in that key. And 20 is nothing but a node, which is 50 times found out in that key. How much time we just find out that in the given tree, that is called as an frequency. So this is a frequency. 34 is a frequency of key 10, 8 is a frequency of key 12, and 50 is a frequency of key 20. And how we can calculate the minimum cost? As per the previous session, when we draw the possible diagrams, means which starts from first node, then second, then third, then again start from second, then first, then third, then again third, first, second, or third, second, first, then how much possibilities are done with the help of these three nodes. This is nothing but the tree structure, which is called as a simple binary search tree, and which is multiply with that frequency as per the visiting number. So for example, if 10, 12, and 20, so this is the possible BST, which is I solve the two cases, remaining one you can solve. Then in first one case, the cost is which is 34. So this is the first node, that's why which is visited first. So multiply by 1. Then second one, which is 8, which is visited at the second time. Then 8 multiplied by 2, and 50, which is visited to the third time. That's why 50 multiplied by 3. So 1, 2, 3. These are nothing but the visited sequence. So firstly we visited to the 10. That's why the frequency of that 10 is 34. So we visited 12. So the frequency of that 12 is 8, which is visited at the second time. That's why multiply by 2. And then the 20, which is the third one node, which is multiply by with 3 with the frequency of that 20. So do the addition of that 3. The calculation is 200, which is a cost for the case 1. Same for the second case. In second case, we arrange the given node as in a sequence of, which is we start from the 12, then 10, then 20. Means 12 is a root node, then 10 is a left hand side node, and again 20 is the right hand side of node, that 10 node. So calculate the cost. So again, which is the first visited node? 12. So what is the frequency of that 12 is 8. So first visited node and frequency is 8. So 8 multiplied by 1. Then second one is 10, and the frequency of that 10 is 34. So second time visited to the 10. So multiply that frequency with the number of count, which is 2. We visited at the second time. That's why 34 multiplied by 2. And the last one is which is 20. So this is 20, which is 50 multiplied by 3. Here is a correction. This is 3 multiplied by with 3. So the output is 176, or check out that whatever due to the correction it may be changed. So similarly solve the case 3, case 4, and case 5. So this is the last one case which is considering as a minimum output, which is the first one, the 20, which is the starting node. So see again, check out the keys and frequency. 20 is the first one node. So frequency of that node is 50. So multiply that 50 with 1. Then second one node we getting a 10. So 10 having a frequency 34. So multiply by 34 with 2. And the last one is 12. The frequency of that 12 is 8. So multiply that 8 with the 3. So the output is 140, 142. So this is a minimum. So which is a minimum value 142, which is applying after case 5. So this is a 142 is your final output. This is your final output, which is the minimum cost is 142. So we want to calculate that all the 5 cases, find out the minimum cost and then apply onto the C++ code. So what is the algorithm for that OBST search tree? This is the algorithm, which is optimal binary search tree, which is find out with the help of three variables, or which is called as the 3 inputs. So optimal cost BST in bracket keys, which are the nodes, then the frequency of that nodes, and the number of keys. This is nothing but the input. And what is the output? The minimum cost of that optimal BST. Here in this example, the minimum cost is 142. So check out the source code of that C++. So in C++, we want to perform the OBST. So this is header file with using namespace standard. Because of the C++, we're taking Assigenment.h. Then we want to find out the minimum cost. So check out first of all inputs and the frequency. So integer sum, we want to calculate the addition. So calculate the addition for what purpose? So check out the frequency, check out the low and check out the high. Check out the frequency of that node, then check out the low value, check out the high value, and then calculate the sum. So initially we declare sum is equal to 0, then which is calculated from case 1 to case n. So this is a loop to calculation the case 1 to case n. So for integer k is equal to low, so starts from to the low, means from the first one node to the last one, or first one case to last one case. So integer k is equal to low, k is less than high, and increment the k by 1 each time. So calculate the sum. So sum plus is equal to frequency of k. Whatever arithmetical calculation we done into the before example, which is done with the help of that previous which is done with the help of that for loop, and then return that sum, which is calculated here, cost 1, cost case 1, case 2 up to the case 5. So this calculation is done with the help of this for loop, and then we just write down the sum in here 200, 176, 142. So these are the possible cases which is from low to high. Then how we can calculate that this is a minimum value, which is checked with the help of less than and greater than. So this is a code which is used for calculating the minimum cost. So here in minimum cost BST, again we having a 3 inputs, keys, frequency, and the number of nodes or number of entries. So which is applied with the help of n by n matrix. So integer cost n multiply by n, row and column. So n is first one, n is row, second one, n is column. So check out that with the help of for loop. So when only one key is moved along with the diagonal elements, we just pass that integer I is equal to 0 up to I less than n, then increment that I with the help of 1. So cost of II is equal to frequency of II, which is simply calculated with the help of that previous calculation. So check out that the length of previous one up to the next one. So this is a code which is used to check out that the initial store infinity. So from row to length plus 1 as an I, check out that for integer length equal to 2, length is less than equal to n, and length plus plus. Same for the I, integer I equal to 0, I less than equal to n minus length plus 1, I plus plus. Then this is for the row, same for the column. So integer j equal to I plus length minus 1, and then plot that with the initially score to infinity. So cost ij is equal to integer max. Same for the next one, which is from the row to column. So for integer r is equal to I, r less than j, r plus plus. Find the cost when r is the root of subtree, which is the second one condition. Then integer c is equal to, check out that which is the minimum. So check out how r greater than I, or cost of I r minus 1 colon 0 plus r less than j cost, or r plus 1 j colon 0 plus some frequency of I and j, or if c is less than cost of I of j, then final cost which is showing in a final output, which is cost ij is equal to c. These are the checking possibilities conditions which are occurred in case 1 to case n, which is a check, which is less one, which is a greater one. This calculation is used to calculate that the minimum cost, and which is minimum cost, which is written with the help of this return cost from 0 to n minus 1. This is a code which is used for the calculating the minimum cost of that BST. Then in main function we want to pass out the input actually. So which are the keys? 10, 12 and 20. Then frequency of that 10 is 34. Then for the key 12 the frequency is 8, and for the key 20 the key frequency is 50, and the number of nodes is n is equal to 3. So the output we want to showing in a final cost of optimal BST is minimum cost BST of that key, frequency and n. So which is minimum? 140 is a 142 is a minimum cost. So output must be given as a cost of optimal by BST is 142.